Okay, chi-square distribution. If you have a bunch of random variables that are independent and identically distributed, following the standard normal distribution. Standard normal distribution means that the mean value is 0 and standard deviation is 1. And then if you take the quantities, the squares of these, and let's just call this y, then y follows what's called the chi-square distribution with degrees of freedom equals to n. Okay? And I did a computer simulation to show you some examples. So for example, when we had 4 degrees of freedom equals to 4, the graph looked something like this. It was skewed to one end. Right? From this, you can figure out the expectation value of y. That's a nice exercise. See, expectation of value of y would be, let's work with degree 4, okay? Degrees of freedom 4. This is e of x1 squared plus x2 squared plus x3 squared plus x4 squared, right? And expectation value is linear, so we can take expectation value of each. Okay. Does anyone know e of x squared? So here's a question. If x follows normal distribution 0, 1, what is e of x squared? Huh?
0.
No, e of x is 0. So this because that's the average, we know that e of x is 0. What would e of x squared be? It can't be 0 because if you square something, it's always positive. You have random numbers drawn from the positive side. You can't have the average as 0. To get average 0, you would need something positive and negative, right? So what do you think e of x squared is? Any good guess?
1.
Why do you think so? That's in fact correct.
Sum of all the values is equal to 1.
No, not from there. Rather, what's true is that I know that the standard deviation is 1, right? Which means the variance of x is, what's the variance?
1.
Yeah, it's 1 squared. Variance is standard deviation squared, which is 1. Okay? But we also have a formula for Vx. How do you get this? There's a shortcut for Vx, right? What's the formula?
X squared minus
E of x squared minus e of x is, e of x squared is equal to Vx, right? So we know this, but what do we know about e of x?
0.
Is 0. So now you have e of x squared as 1. So when we talk about x1 squared, you should really think of this as a variance value. Because if you think about the average of x1 squared, that is same as the Vx, because for the standard normal distribution, e of x is 0, so we actually have e of x squared same as v of x. So when you look at this definition, you should really think of each individual squares as square of the sample variance. If you take some random variable and take the square of that, you're really calculating the variance. Okay, so What's this value?
1.
1. What about this one?
1.
1 again. These are all identically distributed, so their values will be the same. So what do we have? 1 plus 1 plus 1 plus 1, which is 4. Okay? Which says that the average value of this distribution is 4. Now, because this is, I forgot to say, I always get skewedness wrong. When you talk about skewedness of a distribution, you always look at the foot of the distribution. So you have a foot sticking out this way. So you say that this is skewed right. So you have chi-square distribution will always be skewed right. Okay? Skewed right. And because you have some outliers on this right side, the actual 4, which is the average, will appear slightly right of the peak. So it'll be somewhere here. So your peak will always appear, for skewed right distributions, your peak will always be on the left side of the mean value. So this is what you're going to see. And because of the central limit theorem, what's going to happen is that as you increase your degrees of freedom, this will look more and more like a bell curve, so that the peak is going to get closer and closer to the actual mean. Okay? So here's a general theorem that if you have time you can prove, not so hard, is that for chi-squared of degree k, so degrees of freedom equal to k. Let's see. For y following chi-square distribution of degrees of freedom equal to k, the expectation value of y would be equal to k. That's what we observe for right now, right? Degrees of freedom 4, average 4, right? So if you have degrees of freedom k, the average will be k. And also, if you wanted to know the variance of y, that takes a bit more effort, but this will come out to be 2k. And to get this result, a long time ago, I said I'm not going to test you on it, but there's something called like skewedness and kurtosis. Kurtosis giving you how fast something decays to 0 as you go left or right, which was about e of x to the 4th power for the normal distribution. This one gave the kurtosis. And I gave you a formula for this long time ago. That will be required in order to get this one. That's not too important. I just want to give you some feel for what this distribution looks like.